Alright, welcome back. So now we're moving on to using log to find n. Okay, remember n, like we said earlier, that it represents a period, represents number of payments, right? Anything of that nature. So why do we use log? Because in our formulas, we always see that n is always an exponent. Okay, it's always a power up there. So there's a relationship between log and our exponent. Okay. If you go back and look at your log rules, you notice that there's a direct relationship between log and your exponent. Okay, so today we're just going to look at an example to illustrate how to use log to find n. Okay, and what we're going to do today, you can use the same method for any type of question. Okay, as long as the question is asking you to find how long it will take to do a certain thing. Okay, for lack of a better word. So in this case, let's look at this example. So Josie, boy, inherits 2 million from his grandfather. May he so rest in peace. He invests the money at an interest rate of 13% compounded monthly. Alright, so compounded monthly, once again, you know, this is a nominal interest rate. Okay, keep that in mind. He wants to withdraw 30,000 each month. That's suspicious. But anyway, let's take keyword there is that it's withdrawal, and the withdrawals happen every month. Okay. What else do we know? That's all we know. So the question says, how long will he be able to do so? To do what? To withdraw the money from the bank. Okay. So this question is going to illustrate one thing. First of all, how to use n, how to use log. And the second thing is going to illustrate, so actually two things. So the second thing is going to illustrate is how do you know which formula to use, right? So in this case, we have future value formula in our heads, we have the present value formula in our heads. So how do we know which formula to use? Okay, so here's one hint. So if you look at the direction, right, of the money in your account, okay, then you'll be able to determine whether it's a future value or present value. So this looks so much like a loan, right? You have an amount that's accumulating, but you're taking away from it. With the loan, you were making payments and it was getting less. In this case, you are withdrawing from this amount. Even though you have invested it, every month you're taking away from it, okay? So every time you have installments which reduce this original amount, then you're going to use the present value formula. And then every time you have installments that increase the original amount, then you use the future value formula. Okay, so I hope you'll be able to remember that. So in this case, let's get to it. Step number one, so our thinking process here, step number one is we want to find out what n is. So with any question, we always start with our formula. We've determined that it's a present value formula. So our P is equal to x 1 minus 1 plus I to the power of minus n all over I. Okay. Our P in this case is 2 million. It's a lot of money. Our x is 30,000, which is also a lot. 1 minus, in this case, our I is 13%, compounded monthly. We have n is what we're looking for, so we don't have anything there. Close our bracket, divide everything by 13% over 12. Okay, so from this point on, all you need to do is just apply your algebra, okay, until you have n by itself. So let's just fast forward a bit. Okay, so at this point now is when we introduce the log. Okay, so watch carefully. So in this case, if we introduce log on both sides, what you do, if you always have an equation, what you do on the left, you do on the right, so that your equation is not changed. Okay, so if you take log of 0.27, and then we take the log of the right side, 1 plus Okay, this is not a 12, it's an n. Okay, the log, if you apply log to an exponent, the exponent comes down. Okay, so in this case, we're left with the log of 0.27 is equal to negative n log of whatever is in the bracket. Okay, so from this point on, it's algebra again. So let's fast forward. Okay, so now that we're here, so you use your maths and then your calculator rather. So you use your calculator and then you find that n in this case is 118.87, which you're going to round up. Okay, which you're going to round up, and then you convert, depending on how thorough you want to be, you can convert that to years as well. So in this case, it's going to be 9 years and 11 months, approximately. Okay, it's not an exact amount, it's an approximate amount. Okay, so if it was less, right, then you'd get to 118.87. Since you rounded this off, right, you're probably going to be left with some amount. But if you go over, then you kind of guarantee that you're going to consume the entire 2 million within that time. Okay, so that's why we round up all the time. Alright, so that's it for logs.